Dear viewers, in this second part of SQL queries, we will continue uh, to write SQL queries, but we'll be using new clauses and new keywords. Specifically, we'll be using join, having clause, we'll be using limit, and so on. So in the first task, we need to write a query that will get employees that don't have customers connected to them. So as we can see, the customers and employees have a connection via the foreign key sales rep employee number and employees primary key employee number. So to implement it, we'll just select all from employees E, and I will join customers C on the condition that E employee number is equal to sales rep employee number. So, and then I will be able to create a condition where my employee number foreign key is not null. So now this was inside a comment. I will move the comment. So now let's run this query. As you can see, we using join keyword, we're able to do a natural join here. So the next task is to write question number one using exist keyword. So this basically means that we will have to write a nested query. So in order to write a nested query, first of all, I will select everyone from customers where their rep employee number is equal to, let's suppose we have already written an employee and we have aliased it as E employee number. Now, this is my inner query. That is why I will select all from employees E, and I will write where exists. I will open the parentheses, and this query will be fit inside where exists. So now if I run this chunk, it will give me the same result as the code with join, but I prefer query with join rather than nested queries, since join reminds more of the relational algebra. Now we will use nested queries to write a query that lists all product lines with their product count. In order to obtain this count, this will follow the same, so to say, approach as in the second example. So I will begin by selecting distinct product lines. As you can see in this graph, we have distinct product lines. So I will be selecting them. Then I will count all the products for which the foreign key product line is equal to product lines of primary key. So let's implement this. I will be selecting distinct product lines from product lines Now I will alias this query as SPL product line, and then from this query I will be selecting by condition product line. I will alias this as something more comfortable to read, and I will be selecting count of all elements that are inside products table, and I will select on condition that product line is equal to product line. So here, let me just, since I wrote it with a mistake, product line. Now, in the end, as you can see, our semicolon is written. So if I run this query, now I have an error. Yeah, since I didn't have product line field. So this is it. Now I will alias this one as well. I will alias this as product count. And if I run, you can see that here is the product line and here is the product count. So this one was a bit longer since it required nested queries technique. Now let's continue. In fourth, we have the most sold, most varied product. We will do this with the help of grouping, ordering, and then using limit. So therefore, I will select. Let me write where I will select from products P. Then I will conduct an inner join on order details O, since I need order details for this product. And then what I need to do is to join on condition, as in the first example, on the condition that product code is equal to order details product code. Now I will just be selecting P's product code. No, let me display product name as product name, and I will also count all as product count or order amount. Let's call this order amount. Then I will group those by their names. Then I will order them by the order amount. I will use descending order, and then I will limit this with 1. So if I don't limit this, you can see that it shows the products by their popularity. And if I limit this, only Ferrari will remain, 1992 Ferrari. So limit 1. So we have Ferrari Spider Red, and it was ordered 53 times. In the final question, we'll use join query, and I will be querying university database. I will show the courses which contain more than 2 prerequisites. So I switched to university database. Now you can see this is the university database. This is the prereq and this is the course. Now using course ID and prereq ID, I will be selecting those courses that require more than 2 prerequisites. So I will select course title. I will select them from course C, and then I will join prereq table on the condition that course ID will be equal to prerequisites course ID. Then I will group them by title. And in the end, since where keyword cannot be used with aggregate functions, I will use having clause, having count key prereq ID. Now this is my condition. So this is my condition. So I count how many prerequisite IDs are needed and select those which have more than 2 or equal to 2. So these are the courses that need more than 2: heat transfer, mobile computing, environmental law, and so on. So thanks for watching. I hope this was helpful.